going to take this little Arduino and animate lights in this building.
This video is brought to you with support from my patrons on Patreon. These videos would not be possible without them, and if you'd like to join the Patreon community, you can follow the link in the description below and join for as little as $1 a month. We're going to be doing this project inside of an HO Scale Design Preservation Models kit. These are great simple kits to do a lot with. If you want to see how I built the kit to this point, I'm actually going to make this a brand new feature on Patreon, and that's going to be a patron exclusive video. You can access that at the Signalman level, which is the $2 a month level, and up. Okay, let's get to the build. The first thing I need to do is figure out the size of the floor that's going to separate the first and second stories, because I am going to need something that can block the lights from the various windows. We're basically building an interior for these buildings out of this styrene. This is a 0.04 inch styrene, which is still thin enough to be easily cut, but it's thick enough to where it doesn't let a lot of light through. You'll notice that I'm using a square here. A square is a great tool to have as a model builder and a model railroader. It just makes getting those slightly more precise cuts done. And now, when I cut this, you're gonna see me go across it several times. And basically what I'm doing is I'm scoring and snapping, which is a great way to get a nice clean line when you're cutting styrene like this. Now, you gotta be careful. You can see I moved around a little bit. So you really wanna hold it down. If you can't hold it down with just your hand, you're gonna wanna grab something like a heavy 1-2-3 block or something and get some nice scoring lines so that you can snap this section off. So we're going to throw it in there and it fits perfectly. Luckily we have that little entranceway that actually works as a great support for that. So now I need to mark off where I'm going to be putting the walls, and I'm going to run a wall in between the front and back windows on the side wall. So I mark that off and then I draw a nice line because I'm going to be gluing another piece of styrene perpendicular to this one to be the kind of sort of back wall. I also marked off sections of where the windows are going to break and break up the rooms for the second floor. So I'm just going to stick this in there, double check it, make sure everything is good, make sure it lines up with the windows because we don't want a wall going through the windows. Looks like we're pretty good there. One of those sections is actually going to be where the wires come up into the second floor. Now that line you just saw me draw is for the wall on the first floor. We're going to block off the back half of the building and not have any lights in it. This is important for giving your building realism and depth. Not being able to see through the entire building, it just does a little bit something to the eye that makes it look a lot more realistic. All right, so now we are cutting off some more styrene. I'm just going to go ahead and cut off a section of this sheet, and we're going to use it to make our various walls. That way, if I mess up, which is sometimes something that happens, like right here where I had a little bit of a hiccup on getting the clean edge, so I had to cut a little bit extra off. It's always good to have some extra to work with. Remember, you can always cut some more away, but it's really difficult to add some back. So I'm doing a test fit right here for the wall on the first floor, and then I'm going to mark roughly where I want it to be, and then we're going to cut it and we're going to glue it. I always do a bunch of test fits before I'm ready to do that. And this is where 1-2-3 blocks come in. I'm going to put a link to these in the description below. These are absolutely crucial to model making, especially if you're doing right angles. And I'm using some Tamiya Cement, and basically what this does, it does a chemical reaction that almost pretty much welds the two pieces together and will kind of melt them and then fuse them. And so this stuff is really great for using on styrene. It just needs a little bit more time to set up. So I'm using the 1-2-3 block there to hold it in place while this sets up. Doesn't need a ton of time, but this gives you probably the most solid bond you can have with styrene. Now to hold it in place and make sure that it's set at an upright angle, I actually took two 1-2-3 blocks and put them together, just holding it and kind of pinching it right there so that we didn't get any runoff. And then once it was done, you can see it's really solid and it works really, really well. Alright, so we're going to do a test fit. You always want to do some test fitting. Now it's time to put the second level front to back wall. But before that, we want to go ahead and drill holes for the lights. Now you'll see that I'm using a drill bit and I'm hand cranking it. If you were to use an electric drill with styrene, one thing I've learned is that the styrene can sometimes get hung and spin and it can destroy what you're working on. So when I need something large, I'll just grab a drill bit and just crank it through manually. And I'm punching 2 holes right here. One's going to be for where all the lights wires run through in the back, this one is, and the other one is for where the other light is just going to barely punch through onto the first floor, because that's going to be the most visible one, so I want the light as hidden as possible. Now it's time to do another front to back wall, this time for the second floor. So I do a rough mark on it and then I go ahead and do my scoring and snapping so that I can put this second story wall in place. Now we do have to glue this one slightly differently because we have the first wall in place. We just can't simply sit it on the ground and have a couple 1, 2, 3 blocks holding it. Now I own 4 1, 2, 3 blocks in total, so I have the 2 that are holding it in place, and then I have a third one that's going to hold the rest of the section that's built in place, and then I have a fourth one that's going to hold that wall to the second floor right there. So, and then I'm just going to use some more of the Tamiya, and this stuff works really great. I really love it, and this is going to glue that right together, and then I'm just going to leave it sitting in place until it is dried, and then we can work on the other walls. And here is our completed section with the first and second story front to back walls. Before we go ahead and put in the final 2 dividers, I'm going to drill a little hole where these wires are going to go, and then I'm also going to run the LED wires, just test fit and make sure that the holes I'm drilling at the smallest size are going to hold the LEDs, and they are, so we can go ahead and continue on with our work. I've got a couple more holes to drill in this section, and then we will be good to go. Now we can do the last 2 walls, and I have to glue these a little differently. The sizing is pretty much the same, but since we have the edges, everything, we just have to match those up so we don't have to sit it in and test fit until we're done. So I basically got the cuts and I did that. Now, because I can't get the 1, 2, 3 blocks in there to hold it in place, I'm actually using a little bit of Starbond high viscosity super glue to do the initial hold in place, and then while that's holding, I'm applying some of the Tamiya cement so that can do the final bond. Think of this as like when you build your bench work and you use a nail gun to initially hold everything in place, or screws depending on what you're doing, but you also put wood glue to do the final hold in place. That's kind of what you're doing here, and I did double check as I was going. I wanted to make sure there wasn't any weird chemical reaction because I've actually never put these 2 right next to each other at the same time. I didn't feel any heat or anything like that, so not 100% sure, don't take my word on that, but I think they're fine to mix together. Once that is dry, I just repeat the process for the back wall. Now that small section with the large hole in it, it is not going to have an LED in it. That is where all of the wire bundle is going to come through for the rest of the LEDs, which is why I'm making it so small, and because it fits the windows pretty well. The next thing I need to do to this is I need to drill a decent sized hole so that we can have 1 LED popping out into this larger section and another running into the front second story window over there. So basically 4 wires need to fit through this hole. So I'm going to use kind of my in-between drill bit. And we're going to do a test fit. This thing is pretty snug and actually a little bit difficult to work, so you're going to want to be ginger with it, but the cement, once it dries, it's going to hold it and make it pretty rigid. So it takes a little bit of finagling to get in there, but once you're in there, you can make sure that your test fit is okay. So the good news is that my walls fit great, don't have anything overlapping, but the bad news is that the second floor is just a little bit too tall, and I'm gonna have to do a little bit of trimming. So I brought the roof in here and it did not sit where I needed it to. So what I basically did is I don't need this trim to be super pretty, but I need to be able to get it off, and I could have sanded it, but that's also maybe a little rough. So what I did was I took my flush cutters and just trimmed off a little bit on each side and made it as even as possible. And then once I had that trim, I brought in my file and I sanded it smooth so that when we eventually go to install this permanently, it's going to have a nice smooth surface for the glue to grab onto. And now the test fit works great, the roof fits great, and I am very happy with it. So normally when I do these Arduino projects, I do a whole build for all of this, but this is really, really simple. I have a schematic of it. I'm going to put that up right here, as well as have it with the code that's going to be on the GitHub link in the description below. Basically what we have here is we have all of the wires for the LEDs going into the common ground, and then we have each one of the LEDs going into, one's going into pin 3, one's going to pin 4, one's going to pin 5, and one's going to pin 6. Now, these are 9 to 12 volt warm white LEDs, so they don't need a resistor because we're only talking about Arduino's outputting about 5 volts of power max. So we don't have to worry about any of that. It's literally just hooking LEDs into a common ground and then also hooking them into those 4 digital pins, and just make sure they're separated out. Now here I'm using an Arduino Nano, and I have a little Nano shield, so it gives me little screw terminals that make things a lot easier. But as long as you have 4 digital outputs, you can make this project happen on any Arduino. And I am going to demonstrate this project really quick in the prototyping phase. I love the shield because it has the DC barrel plug jack, so I can just plug this right in. And you can see what this is programmed to do is basically have 1 or 2 lights on at the same time. And you can see it kind of blinking. This is actually sped up, so it's not going to blink this fast. But let's go ahead and start our coding. So we're going to write a little bit of code for this setup, and I promise you it's very easy. It's very simple. If you've done any sort of coding in the past, it's going to be really, really easy. And my setup is probably not the cleanest or the simplest coding you can do, but it is very easy to understand. So the first thing we need to do is we're going to declare some integers. So we're going to do int random light 1, and then we're going to do int random light 2. And what that's going to do is that is going to be 2 values that we can store that will be the representation of which lights we're turning on and off. Then we're also going to need int time on. So what that's going to be is a number that is randomly picked to say how much time that our lights are going to be on. So that's it for our integers. Now we can hop into our setup. And what we're going to do for our setup is we're going to do pin mode, and we're going to do 3 comma output. This is just saying that our digital pin 3 is going to be an output. Pin mode 4 comma output. Pin mode 5 comma output. And pin mode 6 comma output. And that is because we are using pins 3 through 6 as our outputs for our lights. And that is literally all the setup that you're going to need to do. So now we're going to go ahead and go into our loop. And our loop, we're going to go ahead and delete the line right there. And then we're going to go ahead and say random light 1 is, that's what 1 equal sign means. That's important. It's going to come up later. And equals random, which is a command, and it's going to select a random number between 3 and 7. Now the reason that I am doing 7 is because originally I had it as 3 and 6, but it wasn't picking 6 very often, if at all. And when I switched to picking 3 and 7, it picked the number 6 light a lot more often. So it still may have a few kinks, but putting one number above I found that works a lot better with this. And then we're going to do random light 2 is random 3 through 7. Now, one thing we don't want is we don't want the random light 1 and 2 to be the same value. So what we're going to do is we're going to go ahead and do an if-then statement. So we're going to do if random light 1 is equal to, that's what the double equal means, random light 2, then we're going to put our brackets, our curly Q brackets, we're going to do random light 2 is random 3 through 7. So what that's going to basically do is that if the two numbers equal, it's going to keep repicking the second random light until we go to our next statement, which is else if random light 1. Now we need to do not equal, so that's exclamation point equals. That's does not equal random light 2. Put our curly Q brackets. We will type time on, then do is, so 1 equal, random 500, 5,000. Now, this number can be different for everyone. Basically, what I'm doing is saying that it's going to pick any number between these to represent the time. So time on an Arduino is measured in milliseconds. So 500 milliseconds is half a second. 5,000 milliseconds is 5 seconds. So you may want this to be a lot longer because your display may be up. I'm just having these times set for demonstration purposes. So let's say you wanted it to be between 2 and 3 minutes. So you would do 2 minutes is 120 seconds. So that's 120,000 milliseconds. So you do 120,000. And 3 minutes is 180 seconds. So 180,000 milliseconds. So you do 180,000. And that would be your number. But for this demonstration, I'm going to keep the 500 to 5,000. And that's going to be our decider. So what we're going to do next is we are going to start typing in our digital write. So digital write random light 1, comma high, that turns it on. And digital write random light 2, comma high, and that will turn on the second one. Then we need to do a delay, and we're going to type in time on. So that's our variable, remember our integer, and whatever this selects, whatever it randomly picks, it's going to put here. So whatever that is. So it'll be different every time. So then we're going to do digital write random light 1, comma low. That's going to turn it off. Then digital write random light 2, comma low. And that's going to turn that off. And voila, that is all of our code. Let me look through it, make sure I didn't have any typos that I can spot immediately, because it's going to let me know. But you can see that's not a lot of code. Let me see if I can actually turn on the viewer here. So you can see that grand total, and I can actually probably eliminate some of these lines, like with my terrible formatting and all that kind of stuff. It's only 27 lines of code. It's not a lot. So there we go. Let's go ahead and check this, make sure it's good to go. Good to go, only uses 5% of storage space, and we're going to go ahead and upload it to our Arduino. Now it's time to wire up the lights for real. So I pulled the insert back out, and we're going to go ahead and run all of our lights. We're putting 4 lights into this particular setup. This is the first light that has to go through that pass-through, and then down to where our wires are going to go out. And then we're going to go ahead and put the rest of them in and get them into position. And then once we have them into position, we're going to use a little bit of hot glue to put them all in place and hold them all in place, because I do want the lights being held. I don't want them to move around too much or have a little bit of tension that makes them pop in a weird direction. So we're going to get these lights all run, get them glued in place, and then we can start doing a little bit more wiring. Next up, we're going to do some soldering. I'm going to solder all of the ground wires together onto a single feeder, as you can see right here. And then I'm going to slide a little bit of heat shrink tubing on here. If you don't know what that is, basically you can slide it over anything like a solder joint or a wire joint, and then apply a little bit of heat to it. It's going to shrink right up and seal in that joint so that it is not exposed. Once I've done that, I'm just going to be soldering extension wires to all of the LED's positive sides, and I'm going to be using different color wire just so that they all look a little bit different. And then it's just a little bit more heat shrink tubing, and then we can get to connecting them to the Arduino. To start with the Arduino connection process, first of all, I'm going to strip all of them, and then I just need to connect them to their screw terminals that coordinate with that digital pins 3, 4, 5, and 6. So going to go ahead and connect all of those up. And you can see right here, this is just basically what I have right here. I have the 4 positives connected digital pins, and then that black wire, that common ground. Let's take a look at what we got here. So I'm going to plug it in. And here we go. Here is the finished product. You can see it changing itself up just a little bit, lighting up different random rooms. And here's a look from the top with the roof off, so you can see the 3 different second story LEDs turning themselves on and off at random. Remember, you also have that first floor LED as well, so you can kind of see what's going on here. You can also see how that 0.04 inch styrene really does block a lot of the light. So that's why I like that thickness. It's just kind of a good middle ground if you don't need anything too specific.
Whether you're looking to add some animation and life to your layout, or you're a beginner with Arduino looking to dip your toes in it, this might be the perfect project for you. It's simple to code, it's simple to wire, and it's fairly easy to create if you can get the model, and you can do this with any model that you have already. So if you want to check out some of the parts and tools that I've used in this, I've linked them all in the description below. Thank you so much for watching. Until next time, I'm Jimmy from the DIY and Digital. Stay safe, be kind, and happy railroading.